Good afternoon, everybody. It's always an honor to speak at the AMLD. Today, we're going to talk about urban resilience and how machine intelligence can help better understand it and improve it. I'm Luca Baldassarre, lead data scientist for Swiss Re, and Alicia, my colleague, she's head of research commercialization for the Swiss Re Institute, our R&D branch. As you might have guessed, I'm Italian, actually from a town called Genova. How many of you know where Genova is? Raise a hand. Many of you. If I had asked this question 2 years ago, probably fewer hands I would have seen. Why? This happened. Big bridge collapsed. So what actually happened? The bridge collapsed. So there was some insurance attached to it. People died, insurance attached to it. People had to go to the hospital, insurance. People may have long-term disabilities, and then also there's some sort of insurance that can cover for loss of capability of working. Buildings were destroyed underneath, property damages. Businesses had to interrupt their operation, may have lost their warehouses, their goods might have been broken, have been broken. Cars, obviously, got destroyed, damaged. But effects don't just limit themselves to the event time. This event had ripple effects on the entire city ecosystem. The traffic had to be rerouted through a different artery through the city. This implied, for example, that big trucks that were using this bridge to go from, for example, from France to Tuscany had to go through downtown city, changing pollution level, noise levels, and this has an impact on the local population that might, in the future, develop maybe lung diseases or other diseases. The businesses, even if they're not directly affected by the fall of the bridge, since the traffic changed and some areas had to be cordoned off because they were too dangerous to go, they completely lost the customers and the businesses. And furthermore, this does not just affect Genova, but it affects the entire region, because Genova is a big seaport where big container ships arrive from different parts of the world. These containers then are put onto trains or trucks, and these trucks use this bridge to go, for example, to Milan, Turin, or other parts of northern Italy. So the entire region had affected. So it's important to map all these interconnected relationships and how one event on some critical infrastructure has all these ripple effects. If we had been able to understand all this chain of events, maybe we would have been able to convince the local government to do some preventive measures to avoid the collapse of this bridge. Preventive measures that are costly. And that's why they were so unpopular. Nobody wanted really to stop the traffic. But if we could really bring data to say, look, stop the traffic now to avoid this huge disaster later on, this would have maybe convinced them to take action earlier on. And this is just to introduce the topic that the Swiss Re Institute has launched a new R&D initiative called Quantum Cities.
Thank you. So yeah, incidents like Genoa highlight the need for a new approach. So we need to look at the entanglement inherent in these new cities in this globalized economy. Now the world is changing, and it's changing fast. The world population has doubled in my lifetime, and I'm not that old. Today there are 37 megacities with more than 10 million people. 600 of the world's largest cities account for 60% of the world's GDP. The world will build an entire New York City every month for the next 40 years. Now, these are very dramatic changes that are changing the risk landscape dramatically. And as these cities concentrate, so does the risk. Swiss Re is a risk taker. In fact, it is a financial cushion to the governments and insurance companies that we all rely on to save us when disaster strikes. So We launched Quantum Cities in order to better understand the entanglement inherent in digital economies and societies, and to design solutions in order to help predict and prevent risks before the risk happens, to better respond to risks once the risk is happening, so an event occurs, and also to design better solutions for after the risk has occurred in order to help everybody bounce back faster in the face of disaster. So we work together in public-private research partnerships, in fact, probably with many of you in the room and the organizations that you study with or work with, in order to have a pluridisciplinary approach and take into account all the different aspects of the risk. Now, Luca pointed to the ripple effects of an event, and it's really important that we can quantify that accumulation so that we can start driving better decisions, both on infrastructure investments from the government, but also companies. How can we incentivize better risk behaviors? And many challenges remain in order to design some of these solutions. So we're looking at how new technologies, from IoT to 5G to machine intelligence, distributed ledger technologies, to see how can we build an understanding around data and so that we can have interoperable data systems. How can we build trusted, scalable, decentralized networks that we can all share in order to be able to build global systems that interoperate? What are the new opportunities that, for example, 5G brings in terms of autonomous vehicles and the risk predictions that we can now make by linking connected infrastructure, connected cars, mobile phones. So these are the kind of areas that we're researching in order to develop solutions that will be economically, environmentally, and socially sustainable. Now, the same piece of data can be looked at from very different angles. And it's part of the reason how we came to quantum cities, because all these different aspects of the same data have repercussions across what we typically look at independently, but actually within quantum cities, we look at together. So you can't design a mobility system without thinking about energy, without thinking about health, without thinking about supply chains. We have limited real estate and resources, and we need to make the best use out of those. And so when we look at these topics, we need to look at how they interconnect. And I wanted to invite Luca back to give us a few examples of how we're using machine learning to address some of these issues.
Great, thanks. So as you've seen, it's a complex topic. There's a lot of moving parts, and what Swiss Re Institute is driving is really trying to create a framework on how we can fit all these moving parts together. What I'm doing, my team is doing, in group operations, our data science competence centers, is to work on some of these topics more in a bottom-up fashion. Because we are already starting working on, for example, better understanding supply chains with some of our clients, that want to better understand their exposure to, for example, an event that affects a supplier. How does this, again, has multiple effects in the motor industries? Which would be for example, questions are, which are the large automotive companies that are affected if a factory burns down or kind of shuts off in Thailand due to a typhoon? So what we're doing, we're using data, internal data, clients' data, but also aggregating with the commercial data sets and also kind of other publicly data sets to start reconstructing piece by piece these networks of suppliers and OEMs and manufacturers, and then using kind of data science techniques and graph analytics techniques to assess and quantify the robustness or resilience of these chains, and start simulating what would happen if I remove this node, or if I decrease the bandwidth of a certain edge, so kind of reducing the amount of supplies that go from one supplier to a manufacturer. And on top of this, we start superimposing kind of risk maps, for example, from natural catastrophes. There is other teams at the Swiss Re Institute that they're modeling natural catastrophe events, so kind of getting more and more accurate predictions of where earthquakes, floods, wildfires, typhoons, and the likes will strike. And then we can start to become a bit more forward-looking about exposure and risk, saying, look, there is a high risk of a typhoon happening in this northern region of Japan. There are a lot of factories that are the unique suppliers of this piece of equipment for this particular group of large manufacturers. So maybe we can take proactive actions of the insurance becoming not just covering for losses, but as a risk prevention service, telling kind of the manufacturers, look, start shifting your supplies to a different region, because then you can prevent a business interruption due to some natural catastrophe events. So these things are more and more interlinked, and then you can see also, and very dynamic, with, for example, 3D printing is something that we're looking at because it's going to change the nature of the supply chain. And self-driving cars, the same. So we can analyze self-driving cars in many different ways. From their supply chain, of course, they have one. From the kind of real-time monitoring of the systems, can we glean insights, predictive insights on where kind of we can also think about disasters in terms of traffic when we talk about a system like self-driving cars, where the drivers may no longer be uncorrelated like us, but maybe a fault in a self-driving car system may affect multiple cars simultaneously and cause a massive, for example, traffic jam that's going to affect people involved, but the businesses that are not reached by these people, the employers where the employees cannot reach. So all these things are tied together, and especially what's new now. Why? I mean, we knew this before, but nowadays we have more sensors, we have more data, and we have more capability of making sense of this data with the machine learning, data science, just starting to visualize all this data in different layers in one place so that we can provide more insights about the risk landscape. So this is a very exciting work that we're really looking forward to work together, because cities are the place where most of us are going to live in the future, are becoming more complex, and we want to make sure that they are the best place where to live. Thank you very much.